All right, peoples. I'm going to go over all 6 questions of this Hess's Law worksheet. Please make sure you watch all of the problems and make sure that your answers are correct and you know what you're doing for your quiz tomorrow. Okay? All right. So remember the 3 questions that you have to ask every time you do this kind of problem. The first question is, does the given equation have anything that I want? Then the second question is it the correct number of things? And the third question is it on the correct side? So the yellow highlighted equation, that is our overall equation, okay? The overall equation is where we're trying to get to. We're going to solve the 2 equations that have been given along with the enthalpy terms here to try to get the overall equation. So we're comparing these equations to the overall equation, okay? Because we're trying to find out what is delta H for this highlighted equation, all right? So let's look at the first equation. Does the equation have anything that I want? So if you look at it carefully, you can ignore these states of matter. Those are in the parentheses. You can just ignore them, okay? So if you compare this and this together, you'll notice that carbon is something that we want. And then we also want O2. However, we only want 1/2 of the O2. So if that is the case, that means at some point it's going to resolve so that we get 1/2 O2, okay? Remember, check the second equation to see if that also has O2. It does. You can just trust that when you do the manipulations, it will resolve. So because O2 is present in the first equation and the second equation, I'm going to give carbon priority. I have the number of carbons that I need. That's the second question, right? Is the correct number of things? Is it on the correct side? Yes, it is. So I shouldn't do anything to this equation. I should just write it out. So C plus O2 goes to CO2. Again, you can just leave out the states of matter. Not a problem. All right, if I look at the second equation here, I'll notice that I need CO. CO is here and CO is here. It is the correct number of COs, but it is not on the right side. So for the first equation, I did nothing. But for the second equation, I have to reverse it. Remember, O2 is present in the second equation and the first equation, which means O2 will resolve. It always does, okay? So pay attention to the CO. We want CO to be a product. So I'm going to now make this equation reversed. So I'm going to write CO2, which is the product here. I'm going to make that a reactant. CO2 goes to CO plus 1/2 O2, all right? And the delta H for that, the negative must become positive because I reversed the equation. So this is reversed, okay? So let's see if I can get the components I need. I need carbon. I have carbon. I'm going to write that here. Plus, I need 1/2 the O2. So look over here. I have 1 O2 on the reactant side of this first equation, and I have half an O2 on the product side. So this is in the reactant side, this is in the product side, which means they're on opposite sides. If they're on opposite sides, they subtract. So that is 1 minus 1/2. That actually gives me 1/2 O2. Okay? If they're on opposite sides, they subtract. All right? Then I need CO. So there's my CO, arrow, CO. Okay? Now you also must make sure that you cancel out the things you don't need. You'll see that CO2 here is on the product side, CO2 here is on the reactant side. Cancellation means you're subtracting, okay? There's 1 minus 1, that means there will be no CO2s left. The reason we had half an O2 here is because there's 1 O2 here and only half an O2 here. So 1 minus 1/2 leaves us with 1/2, okay? Now that I did that, I can resolve the delta H for this reaction. Let me grab my calculator. So 393.5 plus 283 gives me 110.5, negative 110.5 kilojoules. So for your quiz, I expect all of this work. Even if nothing is done to the equation, you still have to rewrite it. And you have to show what you've done and then rewrite it and then rewrite the delta H's and then resolve it. Okay? Now this one requires a little bit of subtraction and a little bit of thinking. So we are trying to get to this answer so that we can find the delta H for this equation. Okay? So let's look at the first equation and ask the question. Does this equation, this one, have anything that we want? Yes, it does. It has the PCl3 and it has the Cl2. So the PCl3, the next question is it the correct number of PCl3s? No, it's not, right? We need two of these, but we need one of these, but we have two of them. And we need one Cl2, but we have three Cl2s. So let's see which compound we should give priority to. If you look at the second equation, you'll notice that PCl3 is not present in the second equation, but Cl2 is, which means Cl2 has a second chance to fix itself, but PCl3, we have to fix it, okay? So the second question, is it the correct number of things? No, it's not. How do you get to the correct number? You have to divide this by 2. Divide the whole equation by 2. And then the third question is it on the correct side? It's not. Here the PCl3 is a reactant and over here it's a product. So I have to now also flip it or reverse the equation. So I have to reverse and divide by 2. So let me divide by 2 first. 2 divided by 2 gives me 1 PCl3. 3 divided by 2 gives me 3 half Cl2. And then 2 divided by 2 gives me 1 P. Okay, now let's flip it. PCl3 becomes a reactant now. Goes to P plus 3 half Cl2. Totally fine to leave it as a fraction. Okay, delta H here, you have to reverse the sign. So this becomes positive. 640 divided in 2 is 320 kilojoules. All right. Let's look at the second equation. First question, does it have anything we want? Yes, it does. It has PCl5 and Cl2. Is it the correct number of things? No, it's not. PCl5 is the only thing that is unique here. Cl2 is in both equations, so we give priority to PCl5. Question, is it on the correct side? Yes, it is. So you don't need to reverse it. You just need to divide it by 2. Divide this by 2, divide this by 2, divide this by 2. That gives you 2 over 2 cancels out. You have P plus 5 halves Cl2 going to PCl5. Okay? And the delta H is still going to be negative 443 kilojoules because I had to divide that by 2. And this one I reversed and divided by 2. Okay, now let's see what we can do. We want PCl3. We have PCl3 right there. We want Cl2, but we have 3 half Cl2 and 5 half Cl2. This is on the product side. This is on the reactant side. The reactant side has 5 halves. The product side has 3 halves. So it's a subtraction because they're on opposite sides. Look at this. 5 halves minus 3 halves gives you 2 halves. 2 halves is just 1 whole. 2 over 2 is 1. So we have 1 Cl2. So 5 halves minus 3 halves gives you 2 over 2, gives you 1 Cl2. Okay, that's how we got our Cl2. And then we need the PCl5. And you'll notice that these will cancel out because this is a product and this is a reactant. And it's not something we need in our reaction, so we cancel it out. Okay, and now we can solve for our delta H, which is going to be 320 plus negative 443. That gives us negative 123 kilojoules. Must use units. Okay. Then problem 3. Calculate the delta H for this equation. So let's see. We're looking for delta H for this equation. Does this first equation have anything that I want? Yes, it does. It has the carbon. We also want O2. There's half an O2, but I'm sure it'll resolve. So we need this and this, okay? The carbon is the correct number of carbons. Since O2 is also present in the second equation, we're going to prioritize carbon. It's on the correct side. It's the correct number, so we're going to just rewrite it as it is. CO. Nothing happens to the delta H. Negative 110.5 kilojoules, okay? Then the second equation, does it have anything we want? Yes, it does. We want the CO2 and we want the O2. Is the CO2 on the correct side? Yes, it is. So is it this correct number? Yes, it is. So we are going to just rewrite it exactly as it is. So nothing was required of this at all, really. All right, let's see how this resolves out. Should resolve out rather easily. You have carbon that we need. We have carbon right there. We need one whole O2, but look at that. 1/2 and 1/2 both on the same side. They're both reactants. That gives us a full O2, okay? And we need a CO2, and that's right there, okay? And then the CO and the CO cancel out because they're on opposite sides, all right? So very easy problem, this one. We have negative 110.5 plus negative 283. That gives us negative 393.5 kilojoules. All right. Fourth one. It looks like there is so many things to write here, but honestly, I don't think this is the complicated one. Just watch carefully, okay? Looks like there's a lot of compounds, and there is. All right. So the first equation, does it have anything we want? So we want TiO2 and we want CCl4. We also want CO2. We don't want TiCl4. So we want all of these. Is it the correct number? Yes. Is it on the correct side? No, it's not, because CO2 should be on the product side. So let's reverse it, okay? So I'm going to write TiO2 plus CCl4 goes to TiCl4 plus CO2. And since I flipped it, I have to make this negative 155 kilojoules. And then the next one, I need the Mg, I need the Ti, and I need the MgCl2. I don't need TiCl4. The number of magnesiums is correct. The number of MgCl2 is correct. So they're also on the correct side. You don't need to do anything to this equation. So I'm going to write TiCl4 plus 2Mg goes to Ti plus 2MgCl2. Okay, the delta H stays the same because I did nothing to it. All right, now let's see. I want TiO2, got that. I want CCl4, got that. And then I want 2Mg, got that on the reactant side. And then, bye people, see you next Friday. Then I want Ti on the product side, got that. And then I want 2MgCl2, got that, right? And that is it? No, we also want the CO2. Plus, we want the CO2, got that as well. Doesn't have to be the same order. Clearly, I didn't write it in the same order. Okay, so we got all of these things that we need. Gonna cancel out TiCl4, TiCl4, which are on opposite sides. It's a long equation, but it's relatively simple in terms of what you have to do. So negative 155 plus negative 478 gives me negative 633 kilojoules. All right. And then number 5, we are looking for this equation to calculate the delta H for. Okay. So let's see what we need. We need, let's look at the first equation. Is there anything that we need from it? Yes, there is. We need the NiO, and then we need the NiCl2. And they are the correct number, and they're on the correct side. So we don't have to do anything to this first equation. We can just rewrite it as it is. SO2 goes to NiCl2. Delta H stays the same, negative 150 kilojoules. Okay? And then let's see. We also need, from the second equation, we need the HCl and we need the water, but they're not on the correct side. So we got to reverse this one. Is it the correct number? Yes, it is. We have the correct number of things. So we just reverse. So I'm going to write 2 HCl plus SO2 goes to SOCl2 plus H2O. Okay? All right, now let's see. We need the NiO. We got that. And we need the 2HCl. We got that. And we need the NiCl2 on the product side. We got that. Sorry, it's loud. The bell just rang for the lunch period. And then we have water. We got that. Okay. Since we reversed this, we have to reverse the sign here. So that's going to be plus 27. Okay. So now we can calculate the delta H for the reaction. But before we do that, let's cancel out. This is on. Mrs. J wrote an extra arrow there. It's like, what's happening here? All right. You have a SO2 here and you have a SO2 here. This is on the product side. This is on the reactant side, which means they can cancel out. And then you have a SOCl2 here and a SOCl2 here. This is on the product side. This is on the reactant side. That cancels out. Okay. So now we have negative 150 plus 27. That gives us negative 123 kilojoules. All right, that's number 5. Let's look at this one. Purple. Calculate the delta H for this equation. We're looking for that. So let's look at the first equation. Does the equation have something we want? Yes, it does. We want the CH4. Is it the correct number of things? Yes, it is. Is it on the correct side? No, it's not. So we must reverse. So CH4 as a reactant going to C plus 2H2. Okay, since I reversed it, I'm going to make this plus 17.8 kcal. Kilocalories, remember, calories are also a unit for energy. So instead of joules, this one has been given in calories. No biggie. All right, second equation, does it have anything that I want? Yes, it does. It has water and it has O2. Okay, so I want both water and the O2. Is it the correct number of things? No, it's not. Is it on the correct side? Yes, it is. Water is on the product side, oxygen is on the reactant side. So that means I have to figure out how to make this 2. So you'll notice that oxygen is also present here, which means oxygen is probably going to resolve. Okay, if it's present in more than one equation, it's going to resolve. It always does. Okay, so let's focus on the water. I want 2 water, so I'm going to multiply this equation by 2. So if I multiply this by 2, right, that means I'll have 2 hydrogens two H2s. Let me actually write that. So I'll have two H2s there. 1/2 times 2 will give me a whole O2, right? 1/2 times 2 gives you 1, right? So that's why I have one O2 there. And then I'll have two H2Os. So two H2Os, okay? Then delta H becomes negative 57.8 times 2 gives me 115.6 kilocalories. Then let's look at the third equation. Does it have anything I want? It has O2, so there's another opportunity to resolve that, and it has CO2. The CO2 is the correct number of things, and even if the O2 is not the correct number of things, that's okay, because O2 in the previous equation will probably help resolve that, okay? Is the CO2 on the correct side? Yes, it is, so I don't have to do anything here. All I have to do is write this in. The delta H is going to be negative 94 kilocalories. All right, now let's see what I can keep and what I can remove. So I want to keep the CH4, right? Let me make it a little smaller so I can fit in the whole thing. I want to keep the CH4, so I'm going to write CH4 down here. Plus, I need 2O2, and it does resolve. See, 1 plus 1 is going to give me 2O2. You can add them because they're both on the reactant side, as you can see. I need the CO2, so that's going to go to CO2, plus I'll need the 2H2O. Okay, and the new delta H is therefore going to be 17.8 plus negative 115.6 plus negative 94. That gives me a negative 191.8 kilocalories. All right. So that is all 6 problems, everyone, for the Hess's Law worksheet. I hope you have watched this on Monday. Have a nice rest of the day. Your quiz is tomorrow, so please make sure that you have your notes and whatnot available to you and that you look through things before the quiz. Okay.